greater than C here. Original, we have a C here, right? From here to here, we have a C. However, for this case, we have A, this A here, the radius of this, and this A is greater than C here. What happened? So for this case, we don't passing through the so-called critical point anymore, right? So as you can plug this exponential delta equal to A EI mu through our transformation function. Okay, this is Jacobi transformation function, and you plug in and rearrange. Okay, you can find out this is our real part, this is our imaginary part. So x is equal to this, and y is equal to this. Okay, and you rearrange a little bit. X divided by this factor is become a cosine mu, right? And y divided by this factor becomes sine mu, because cosine square plus sine square is equal to what? Equal to 1. So we have this kind of formula here, and this formula tells us what? When we have the circle in zeta plane, and this circle radius is greater than C, through a transformation become like this, and this is what? This is a ellipse, elliptical shape, right? 它变成了这个椭圆形。Become ellipse in the z plane. So this is ellipse. So through a transformation from the circle in the zeta plane, and then we will become the ellipse in the z plane. So this is another example. You can see. For this example, we don't pass things through a critical point. Is there any problem until right now? Any question? Just kind of demonstrate, demonstrate how this transformation work, If no question, we can go even more detail. So we have the two cases, right? These two cases. One is a circle passing through a critical point, right? One is a circle is greater than A, this radius is greater than C. So for this case, it reduced to degenerate to the flat plate. For this case, through the transformation, we become elliptics. This is formula we have. We just mentioned these two cases. We're just using this example. So we would like to do so-called flow around the ellipse. Can we do that? We can study the flow around the elliptical shape of the body. So we just mentioned we have through this Jacobi transformation, if the circle is zeta equal to A, its potential I mu, and A is greater than C in the zeta plane, it will be transformed or mapping to the z plane become what? Become the ellipse, right? So flow over a cylinder, we know how to write down all the complex potential very easily, right? So in the zeta plane is the flow over a cylinder. So this is we using so-called we can use in so-called circular theorem we have. Remember what's a circular theorem? If you have this uniform flow, is the angle with angle attack alpha. So in zeta plane, this is a complex potential in zeta plane will be written like this. This will be kind of confused. I would like to change this. This is become capital F is small. But anyway, I using the F. Remember, this F is not mapping function. This is complex potential. Just mark the point here. For this uniform flow at the angle attack alpha in zeta plane, the complex potential can be written like this. So if you want to insert a circle, circular cylinder with a radius A into this flow field, we can use in the circular theorem we mentioned before. And then circular theorem is tell us we can use in the this complex potential plus a complex conjugate of this complex potential, and then argument change to A squared over zeta. For this combination, complex potential here will be give you the flow, uniform flow with angle attack approach to a circular cylinder. So if you do that, this is U EI theta zeta, right? This is just copy. This is equal to this. And for this, what happened? We have to change to complex conjugate. So complex conjugate its potential minus I alpha here should be changed to I alpha, positive I alpha here. And zeta here should be changed to A squared over zeta, A squared over zeta. So this is flow over a cylinder with angle attack, right? With angle attack, alpha. Okay, that's we already mentioned in the previous lecture. So this is in zeta plane complex potential. Okay, flow over a cylinder with angle attack. And we know, through Jacobi transformation, this is Jacobi transformation, we can convert to so-called this flow over a cylinder can be converted to the flow over elliptics, right? Okay, so this is a mapping function. So we can switch, we can rearrange our mapping function, z equal to zeta plus 6 squared over zeta, and then change to zeta equal to z, right? So zeta becomes zeta equal to this. Okay, we just kind of rearrange this equation, becomes zeta equal to z function. Okay, and we substitute this into the zeta here, give you this. Yeah, give you this. Okay, so if you go through this mathematics here, and here we have go through all this mathematics. Okay, so this is just simplify our this formula. Okay, it makes no difference. If you're using this, you'll be very clear. But here, just try to demonstrate even more clear. You can reduce this equation to this equation to this equation, and this equation will represent the complete potential for flow over elliptic. Okay, so similar like this. This is our flow over cylinder with angle attack. This is our complete potential in zeta plane. And this is our new flow over ellipse, with angle attack. The complete potential will look like this. Okay, so that will be just through a transformation. Okay, we can have this flow field, more complicated flow field. Okay, so this is very easily case. Okay, you can write down, if you can write down the complete potential in flow over a cylinder through a transformation, you can write down a complete potential in more complicated geometry. Okay, flow field. And here we also can discuss, where is the stagnation point? Okay, so in the z plane, in zeta plane, we know this point and this point is our stagnation point. So at this location, and these two locations can be written as zeta equal to positive negative A is potential I alpha. So this is alpha, right? This is okay. So this is our z. This is our stagnation point for these 2 points. And then through the Jacobi transformation, we can find out this is our new stagnation point in. So 1 point here, 1 point here. So this is the coordinate for what? For this point and this point will be equal to this. If you kind of rearrange this equation, become real part and imaginary part, you can find out this real part, this imaginary part. Okay, this is the coordinate for this point. For the positive sign here will be corresponding to this point. For negative sign here will be corresponding to the second point here. So this is a new stagnation point in the z plane. We can also find out where is the stagnation point in z plane. Okay. So if you change flow over a cylinder with alpha different angle attack, as you can see, we have alpha here. This is alpha, right? This is flow over a cylinder with alpha. Okay, and alpha can be changed, as you can see, minus pi over 2. Okay, you can written become like this. Okay, become upward flow, right? And this is elliptic flow upward. Okay, this is. So you can. So this, if you do that, you can also if you want to switch, if you want to kind of rotate this flow field to this here, flow over elliptic in this orientation here, you can slightly change, because this also very similar, but the only coordinate system is different. So here C you can change to IV here, and this kind of the transformation can allow you to transform flow over cylinder to the vertical oriented ellipse, by through this transformation. That's another side story here. But But if you write down like this, should be okay. You know only the orientation difference. Okay, so that will be the elliptical case, flow over elliptical shape, okay, and corresponding flow over cylinder, how this related. Okay, and then we also can write down the flow over flat plate L4 here. Okay, because we can reduce if this circular cylinder, okay, through a transformation becomes so-called a flat plate, and this flat plate flow over a cylinder can be converted to flow over a flat plate L4 here. For this case, our A is equal to C, right? Because our previous here, if you remember, okay, this is A here. When A equal to C here, our mapping will be degenerate to so-called the flat plate, okay, from elliptics to the flat plate. Okay, so using this property here, we can have when A equal to C, this elliptic will degenerate to the so-called flat plate. Okay, and also the stagnation point is, as I mentioned here, stagnation point here. When A equal to C, you can reduce to this is 2C. This is also okay, and this is Y is equal to 0. So we have X stagnation point for this flat plate to become the positive negative 2C. A is equal to C, so 2C cosine alpha. Okay, this is a stagnation point at this location and this location. Okay, one is a positive sign, one is negative sign here. Okay. Okay, so that's two stagnation point we also can find. Okay, and also at the critical point. Okay, so this is one of critical point. This is another critical point. This is X equal to positive negative 2C. Okay, will be corresponding to the leading edge or trailing edge. Okay, of this L4 here. Okay, and the leading edge and trailing edge, as you can see, our velocity. Okay. Through a transformation, our velocity will be scaled up, right? And this, since this is dz zeta equal to 0 at the critical point, and dz will go to the infinity here. So that means the velocity field in z plane here, at the trailing edge or leading edge, the flow will goes to approach to infinity. Okay, so that's okay. For this case, okay, but this is not a physical possible, okay. We don't mathematically we will know this is this 2 point, okay. This is a singular point, and the velocity will approach to infinity, okay, according to the Ch4 transformation. Okay, so this is infinity velocity will exist at sharp edge, okay. This sharp edge and this sharp edge, at these two sharp edges, our velocity will go approach to infinity. So this is physically impossible. Okay, this. Okay. So later, as you can see, okay, we would like to fix this problem. Okay, how to fix this problem? How to fix this problem? Because we know this is our what? Infinity. The velocity at this trailing edge, okay, will approach to infinity. Okay, so that will be the physically impossible. Okay, physically, 物理上面不可能发生的事。Okay, so we would like to fix this problem. We will so kind of superimpose additional condition. This condition later we will show you. This is Coulthard condition. And what's the Coulthard condition? Coulthard condition is the flow over L4 here like this. Okay, physically, if you see like flow pattern like this, it's physically impossible. Okay, because our velocity here will be approach to infinity, and velocity here also approach to infinity. Right? So what can we fix? How can we fix this problem? Okay, very easy. By apply the Coulthard condition, and Coulthard condition is what? Since this physical property, this flow pattern is not possible. If you see the real flow pattern, as you can see, this is a real flow field, okay, into the water channel experiment. You can see the flow over L4 here. It's not the stagnation point instead of at this location, instead of this location. As you can see, stagnation point always at this trailing edge location here. Okay, So if you compare the mathematically, okay, and the reality, the difference is what? The difference is the stagnation point at this location, okay, for our analysis is impossible. So we have to apply a new condition called the Coulthard condition. And this Coulthard condition is what? We will force a circulation. We will add another circulation into this system. And this circulation will move this stagnation point from this point to trailing edge, from this point to trailing edge. Okay, so that will satisfy the more reality flow field. So instead of we have this flow field, okay, as you can see, this is physically impossible. So after that, we would like to fix by using the Coulthard condition, and Coulthard condition allow us to kind of put a circulation into this flow system, and this circulation will be allowed to change our stagnation point from this shift or change our stagnation point from this point and approach to trailing edge here. So once we do that, our problem is fixed, right? Because since at the trailing edge, our velocity no longer approach to infinity. Okay, become the stagnation point. That means velocity equal to 0. So later we would like to do that. Okay, I think I will stop here. Okay, later we will more describe about what's the Coulthard condition. Okay, that will be the new kind of a very important kind of condition we have to fulfill inside our flow system.